I'm here with Professor Richard Betts of the University of Exeter and the UK Met Office. Richard is UK co-lead for science on the Amazon Face project. So my first question, Richard, what is Amazon Face?
So Amazon Face is a huge and ambitious experiment in the Amazon rainforest, actually doing an experiment on the forest itself. So we have a miniature model of part of it here. So this is one section of, there's 6 sections like this. In real life, it's a set of towers in rings. Each tower is 30 meters high. The rings are 30 meters wide, and these cranes are 50 meters tall. Within these rings, the towers are releasing carbon dioxide into the forest in order to study the response of the forest to high levels of carbon dioxide that we expect to see in the future. This is so that we can understand better how the forest will respond to climate change.
So what sort of results would we see from this project, and when? How long will it take to get those results?
Well, it's almost operational now. We've been building it for the last 3 years. As I say, it's incredibly ambitious, very technically challenging as well. We hope that it'll start operationally in early next year, but it will probably take 10 years. Well, operationally it'll go for 10 years. We'll get some results fairly soon, actually. Within weeks possibly we'll get some early signs, but really to get like the biggest results we want is going to need several years, ideally 10 years. And the kind of thing we'll be looking at, so we're going to look at all ways in which the forest will respond to high levels of carbon dioxide. So, you know, most people know that generally speaking plants will grow better under higher carbon dioxide, but a lot of the knowledge we have on that is from laboratory conditions, very enclosed controlled conditions, in farming and so on, in greenhouses as well. We need to look at it in the real world. Other experiments like this that have been done in other forests in the world, there's one in the UK, in Staffordshire, there's one in Australia as well, near Sydney, others have taken place in the US. Those have shown that in many cases the growth of forest does not increase so much as you might expect under higher CO2 because of other constraints, not enough nutrients, for example, open to the elements, insects coming in. So we need to have all this kind of real world environment to really see how the forest realistically will respond to climate change and improve our models.
And how does this impact on our ability to model climate change?
So it'll give us more confidence in our future predictions of climate change, particularly the future strength of land carbon sinks, and this is really crucial. You know, under the Paris Agreement, we are aiming to limit global warming to well below 2 degrees, pursue efforts to limit warming to 1.5 degrees. We're probably going to, well, we are inevitably going to overshoot 1.5 degrees within a few years now. The United Nations have come out and everyone has been saying this, everyone knows how it works, because there's so much inertia in the climate system and in the political system. We're at 1.4 degrees already, so 1.5 degrees is not very far away. But if we want to work out how much carbon we can emit to stay as close to 1.5 degrees as possible, we need to know how much of our emissions will be reabsorbed into forests like the Amazon rainforest. And we can only do that confidently if we've got these experiments to prove it. And also, if we do overshoot 1.5 degrees warming and then try and get back down to it, reduce global temperatures, we'll need to actively take carbon out of the atmosphere. And again, we need to know how much we can take up through forests in that way. So it's going to be crucial, globally important science coming out of this experiment.
Brilliant, a really fascinating project. Thank you.